Okay, so this is Notes Unit 6.3 for my Algebra 2 honors class. You guys wanted me to redo this so that you guys can see it, so I'm redoing it. So anyways, we have the objective of being able to simplify various radical expressions involving nth roots. So main point today is that we're doing simplifying. We are not solving it. Solving will come around, but for now, all we're doing is try to get it in simplest form. So let's move on. Um, so example one, use the properties of exponents to simplify the expressions. So in class, I was telling you guys that these are rational exponents, but they follow the exact same rules as when we were going over the properties of exponents. So the main things you guys want to be looking for here is when they have either the same base or the same power. So when they have the same base, for example, this first one, they both have a base of 5. So you can go ahead and use the product of powers property. So the powers, sorry about that, the product of powers property, you take the 5 and you take the 1/2 and you're going to add it to the 1/4. Okay? Finding, okay, so it's going to be the, let's see, 2/4 plus 1/4. You have to get the denominator is the same when you add fractions, so it's 5 to the 3/4. I'm actually showing a couple more steps here than we did in class. All right, so that's how you guys do it if you have the same base. Now, also, if you have the um, power products, then you guys are going to go ahead and distribute the 2, multiply the 2 to the 1/2, and multiply the 2 to the 1/3. So it's going to be 8. 2 times 1/2 is 1, so 8 to the first power, times 2 times 1/3 is 5 to the 2/3. All right, and then we're just going to leave it like that. So 8 times 5, oops, put some equal signs there. 8 times 5 to the 2/3 power. I'm not asking you guys to actually multiply that out. You just have to be able to use the properties here. Um, this third one was actually the one I showed you guys two different ways of doing this. The first way you could do this is you could also multiply this in, which you will get 4 times negative 1/4 is 2 to the negative first power times 3 to the negative first power. All right, using the negative exponent property, both of those will be on the bottom, so it's 2 times 3. Um, and then that's just going to be 1/6. That is one way you could have done that. Okay. Another way you could have done this, so if you like it better the other way, feel free to rewind and look at that again. Since these actually have the same exponent, you can pull that exponent out. It's kind of like factoring, but we don't call it factoring. So this will be 2 times 3, and then we're going to pull the 4 out. Okay, and then this is still to the negative 1/4 power. And now you can multiply it in. 2 times 3, that's going to be a 6. And then 4 times negative 1/4 is a negative 1. I'll put my equal signs here. And that will end up being 1/6. So same answer either way. All right, so next example. This was a pair share you guys did in class. Pair share is very similar to this one right here. So I'm not going to go over that one. Let's go to move on to these ones. All right, so since radicals can be written as exponents, they share the same properties. So now we're going to get into the properties of radicals. But technically, since a radical, well, like it says there, it can be written as an exponent, it just follows the same rules. So what we did in class was first this one. So this one we noticed that they have the same exponents. Okay, so this can be turned into 4 times 16 to the 1/3 power. All right. 4 times 16, 4 times 6 is 24, carry the 2, so it's 64 to the 1/3 power. Okay, 64 to the 1/3 power. Now, with that, if you translate this, so this side, if we want to turn it into radical form would have said at the very beginning the third root of 4 times the third root of 16. Now, just like before, if it has the same exponent, you can pull the exponent off, but same thing with radicals. If it's under the same radical, same root. This is third root. This is third root. You can put it both under the same root. So 4 times 16 is going to be the third root of 64. So what times what times what is 64? That's going to be 4. Okay, 4 times 4 is 16 times another 4 is 64. Oh, we didn't finish this side off. So this side, 64 to the 1/3 power. You can think of it like the third root, which is basically like thinking of it on the right-hand side. Or you can plug this into your calculator. You should get a 4 either way. Alrighty. So moving on to the next one. So the next one, same thing. We have the same exponents. So what you can do is pull the exponent off. So 1/4. So you get 162 divided by 2. Okay. 162 divided by 2 is 81. That's going to be to the 1/4 power. So you can think in your head, since the bottom number is a 4, you want to think about what number times itself 4 times is an 81. And that will be a 3. 3 times 3 is 9. Another pair of 3's make another 9. 9 times 9 is 81. Now for the radical form. So radical 162 over 4th root of 2. Okay, since it is the same root, root 4, you can pull the 4 off and then just put the 162 over 2. Now this part right here does make it easier for you to evaluate this. Okay, 162 divided by 2 is an 81, which is still a 3. So those two answers are the same, it's just different notations. So second example we did was this. So we're going to use the properties of radicals to simplify this. So to simplify this, first off, we don't want to change it into rational exponent form. You could, but I do want to see you guys actually using the radical form all the way through. Since these do have the same roots, you're going to put it under the same root. Okay, 25 times 5 is 125. Okay, cube root of 125 is 5. 5 times 5 times 5 is 125. There you go. All right, so moving on. Radicals in simplest form. So now to get it into simplest form, you guys need to go through these three, kind of like a checklist. So first off, make sure you apply any properties of radicals appropriate. So that's the power of a power, pow-pow, pow-prod, all that stuff we went over in class, okay? Now, after you guys apply all of those properties, next you're going to remove any perfect nth powers, other than 1, because, yeah, 1's useless. Useless 1. Okay, so after you do that, rationalize any denominators. So those are the 3 things you guys need to make sure that you do in order to have it in simplest form. Okay, so first part of our checklist. So first part of our checklist was apply any properties of radicals that are, apply any properties of radicals appropriate. So this first one right here, there's no real properties of radicals that we need to do because there's only one base of 54. There's only one radical of root 3. So the properties don't really fall into place here. So basically all you need to do here is find the cube root of 54. Now, if you have a hard time knowing what the cube root of 54 is just off the top of your head, what you can do is a factor tree. So this is an alternative way of doing this. So as long as you can find 2 factors of 54, then you can start up your factor tree. So 54 is an even number, so obviously 2 will go into that. So that's going to be 27. 2 times 27, okay, is 54. 27 is 9 times 3. Okay, and the 9 breaks up into a 3 and a 3. All right, now the reason why we did a factor tree is because if you look at a root, okay, this index right there, that's called an index. The index is a 3. So what we're looking for is triples. We're not looking for the number 3. We're looking for a 3 of a kind. So if you look right here, there's a 3, 3, and a 3. We got a 3 3 of a kind. So the 3 might throw you off. We're not looking for the number 3, we're looking for a triple. So since there are 3 3s, we can pull a 3 out. Go ahead and cross them off so you don't confuse them again. And there's no other triples, so everything else goes back inside. Make sure you make your index as a 3, okay? And what goes back inside of the radical is going to be the 2, this 2 right here, because the 2 is lonely, has no friends, so it has to stay in the house. Poor little 2. All right, so there you go. That's how you do that one. All right, next one. So this is one that gets a little bit complex. We did this, I think, 2 or 3 different ways in the class. So I'm going to show the most efficient way of doing this. So basically, with this one, we're going to have to do what's called rationalize the denominator. Now, what's going to happen here is that we see that we need a 5th root. So what we do is we say, okay, I need 5 of a kind, but I don't want the 5th root lingering on the bottom. So let me go ahead and write this out a little bit. So it's 5 root 3. So if you were to split it out right now, you need 5 root 4. Okay, so right now, we don't have enough of these 4s. I'm sorry, yeah. So basically we want 5 of them. 4 is a 2 and a 2. We need 3 more 2s on the bottom. Now, what I showed in class though, so I'm going to start this over, is that if you think ahead and you know that you're going to have the 5th root on the bottom, what you can do is go ahead and start to, so let's do this, 5th root of 3 and 4. I'm going to go ahead and turn the 4 into a 2 and another 2. All right, so now what we're going to do is we're going to add in enough 2's so that we can take care of that 5th root. So we need to add on, well not add on, multiply on. There you go. Because now we have 1, 2, 3, 4, 5, 5 2's. But remember, if you do it on the bottom, you must also do it on top. This was Mr. Aguirre's fancy ones. So you have 1 that you multiplied by there, so it didn't change it at all. All right, so we have the 5th root of 3 times 2 times 2 times 2 on the top. On the bottom, we have the 5th root of 2 to the 5th power. Okay, let me move this down some. Whoa. All right, so on the top, we have the 5th root of, now 3 times 2 times 2 times 2. We are looking for 5 of a kind. We can't factor that anymore, so there's no 5 of a kind there, so you just got to put it right back together. 3 times 2 is 6, 6 times 2 is 12, 12 times another 2 is 24. So 24 on the top. On the bottom, the whole point of us doing all those extra 2's was that now we have the index matching the exponent, so they are inverse operations of each other, so that just leaves a 2 on the bottom. And you just rationalize the denominator, which means that basically you don't want it. You don't want a radical on the bottom of a fraction. All right, so moving on to the next example, write the following in simplest form. So with this one, I told you guys that I do want you guys trying to write these in the perfect nth powers. So we want to try to make the powers match the index here. So that's the 3rd root. So we want to get to the 3rd powers. So 125, we've worked with it a few times now. You can write 125 as 5 to the 3rd power. All right, now thinking about y to the 6th, y to the 6th is actually y to the 3rd and another y to the 3rd. Okay. Now, if you're pretty good at looking at this though, since we're looking for triples, 6 is a multiple of 3. So 6 is actually 2 triples. So you don't necessarily have to break it into these 2 separate 3's if you can see that you can actually take out 2 y's with that. So, but just leaving that like that, what you can do here is you're going to do the 3rd root of 5 to the 3rd times the 3rd root of y to the 3rd times the 3rd root of y to the 3rd. Kind of spilling over, but I can erase that. Okay, these indexes matches. Yeah, bad grammar. Um, 3 and 3, so you're just going to get a y there. 3 and 3, you're just going to y there. 5 times y is 5y squared. Wow, that went kind of funky down there. Ah. Okay, let me rewrite that. Sergey doesn't like the way that thing looked. Okay, 5y squared. All right, so with that, let's go ahead and move on to the next one. Let's move this over a little bit. Okay, for the next one. Now this is no longer in radical form. It is now in um, rational exponent form. So first off, make sure you know where your powers are. So this is actually u to the first power. Now 9 is a perfect square, and we're trying to get the 1/2 power. 1/2 power is the same thing as the square root. So it does make sense to do 3 to the 3 squared, u to the first, v to the 10th power, and then 1/2. So we're going to rewrite it like that. Now we're gonna go ahead and take the 1/2, multiply it in. Okay, 2 times 1/2 is 1, so it's 3 to the first power. Okay, u, 1 times 1/2 is 1/2 again, and then v, 10 times 1/2 is a 5, so v to the 5th power. And you just leave it like that. We don't really need the 1 there. U to the 1/2, v to the 5th, and that is all. Okay, moving on. Next one. How many more we got? That's the last one. Okay, so last one. Now you can do a factor tree here. The problem with the factor tree, so I'm going to write this in red because this is the longer way. I'm going to erase this in a second. With a factor tree, you're going to get 5, then you're going to get A, B, 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 and I don't want to write anymore. So you can kind of see where the factor tree takes a while. So instead of writing out the factor tree, look at the index. It's a 5. So you're trying to make perfect 5th powers. So 5, 5th root of, now this 5 right here is to the first power. Can't really do much with that, so you just leave it alone, 5 to the first power. Okay, a to the 5th is nice because that is a perfect 5th power. Okay, b to the 9th is not a perfect 5th power, but you do have a 5th power inside of that. So looking at b to the 9th, that will be b to the 5th times b to the 4th. Because when you put the 5 and the 4 together, it makes your 9 again. Okay? Whoa, whoops. So let me write that again. B to the 5th times b to the 4th. Okay, same thing with the c. So with the c, you can actually break it into, so c to the 13th is actually c to the 5th times c to the 5th times c to the 3rd. Now, you can actually leave these as c to the 10th if you can see that you have 2 pairs of 5s inside of the 10th. So I'm going to go ahead and do that so I don't have to keep writing that. So c to the 10th times c to the 3rd power. Okay, so now let's look at our perfect 5th powers, which is this, this, and this. Those are our perfect 5th powers. Basically, multiples of 5 is a perfect 5th power. So this a is a perfect 5th power, so that's going to come out. So the a comes out. This b is a perfect 5th power, so I'm going to take that out. So that b is going to come out. Now this 10 has 2 pairs of 5s in it, so that's going to come out as a c squared since it has 2 pairs of 5s. 5 times 2 is 10. All right, so the a, the b, and the c are all outside of the radical now. Everything else gets put back inside, so it's going to be 5, which is this 5 right here, b to the 4th, and c to the 3rd. Yeah, fix that 5. There you go. And that's it. There's no denominator, so you don't have to rationalize anything. We applied all the properties that we could. Yeah, so that's it. It's simplest form. Okay, so now this one, So this one's similar to the one that we just did a few steps ago. So we got x, y to the 7th. Now keep in mind, we're looking for triples. 7 is not a multiple of 3. We want to make these y's into a multiple of 3. So next one up of a set, or next multiple of 3 up from 7 is a 9. So I need 2 more y's. This 7 and the 2 are going to make your 9. Now, whatever you do on the bottom, you have to do on the top because you have to make sure you're multiplying it by 1. Y squared divided by y squared is a fancy 1. So you're not actually changing anything. Okay? So, now rewriting this, we're going to get the cube root on the top, x, y squared. On the bottom, we're going to get the cube root of y to the 9th. Now, looking at this, we can see that we have a 9. How many triples do we have inside of a 9? We got 3 triples. So, the top, we don't have any triples, so it stays the same. Xy squared. The bottom, the denominator, the cube root of y to the 9th power is y to the 3rd power, because you can get 3 triples out of that. That is it. Okay. Common mistake a lot of people make, just be aware of it. You can't put these two together. Okay. Reason being that y squared, this y squared right here, is inside of the square root. Or that's not a square root. That is a cube root. So it's inside of the cube root, so you're not able to simplify that anymore. All right. And that is the lesson in a nutshell. It's 21:47 seconds. Wow. All right, well, there you go. So if you have questions on it, feel free to ask me on Monday. All right, bye-bye.